Good afternoon. I'm Andrew Lothian of Scenic Solutions, and I'm broadcasting this from Australia down under. This afternoon, I'm going to be speaking on measuring the aesthetic qualities of rivers. I'm going to cover the community preferences method that I developed to measure and map scenic quality, then talk about the research on the influence of water on landscape preferences, focusing particularly on rivers, and finally discuss a little bit of Virginia's Scenic Rivers program. Community preference method involves photographing the region's landscapes and then selecting from the large number of photographs that one takes, photographs which represent the characteristics of the landscape. Then compare or then set up an internet survey that the community rate the scenic quality of the scenes on a 1 to 10 scale or any scale you devise, and also have smaller groups scoring the components of the landscape, such as water and trees, landforms, and so forth, on a 1 to 5 scale. From all the information and data that is gathered, you can analyse the preferences and quantify the contributions of the landscape components, such as water and trees, on scenic quality. And from all of that information, I'm able then to map the scenic quality of the region. Scenic quality is a subjective characteristic. We gain it through the senses, such as similarly to sound and smell and so forth. But the community preferences method enables an objective measure of it. So although it's subjective, you can objectively measure it. And I use community preferences to measure scenic quality and the influence of components, such as water, on scenic quality. I also use it to assess the visual impact of developments, such as wind farms, on scenic quality. It enables regional scenic quality to be mapped, and because it's based on the community's preferences, not any one person's, it's the aggregate of all the community's preferences. I've applied it to over a dozen projects in Australia and in the UK. The method provides a structured way of quantifying the community's subjective scenic quality preferences, and it can also be applied in urban settings. This chart compares the rating of scenic quality with and without water, and overall ratings increase with the presence of water by about nearly 25%. So it's quite a significant increase, presence of water. The River Murray is an area that is the largest river in Australia, and with its catchments going right up into Queensland, covers about 1/7 of the continent. It's about 1,558 miles in length, which isn't as long as your Mississippi, but it's Australia's longest river. And I'm interested in looking at the section of it in the River in South Australia, which is just a little section at the end. The South Australian section of the River Murray is about 400 miles long. It also includes these terminal lakes, Lake Alexandrina and Lake Albert, and also a linear estuary going along the coast. I did this project in 2006, and it involved photographing the river, assembling an internet survey of 120 scenes, and having nearly 1,700 people rate the scenes. The influence of water can be shown from this chart by scoring the water along the bottom up to 5. You can see that as the ratings or the score of the water goes up, that is, the significance of the water in the scene goes up, so too do the ratings. And so it's very clearly that water influences the ratings. Reflections, the presence of reflections in the water also increase ratings. As you can see here, if it's mirror-like or if it's fair reflections, it increases the rating somewhat compared with no reflections at all. Visual diversity is the busyness of the scene, the combination of landform and land use, land cover, water, colour, and so forth. And it's also the river itself, the various characteristics of the river. And I've always found in my projects that visual diversity is a strong influence on scenic quality. This shows the strong relationship between visual diversity and ratings. As you can see, as the visual diversity score increases, so too to the ratings. The increase is about 1.17. So for every 1 unit increase in the visual diversity score, say from 2 to 3, 3 to 4, the ratings increase by 1.17. And then you can use that algorithm to then derive what the scenic quality of the river, of the landscape would be based on that algorithm. And this chart shows that. Naturalness also is a factor which contributes significantly to the scenic attractiveness of landscapes. It's not necessarily ecological landscape or ecological naturalness or botanical naturalness, but rather how it appears to a lay person. And it involves the absence of any human presence or human artifacts. So even the presence of sheep or fences or farm buildings all affect the appearance of naturalness. And this graph again shows how naturalness increases, so do the ratings. And many of the scenes rated fairly highly on the right-hand side. So it's fairly high, the river scenes in naturalness. And the 0.79 in the algorithm suggests that for every 1 unit increase in the naturalness score, the ratings increase by about 0.79. Land cover, that is the vegetation, trees and shrubs and so forth that clothe the land, provide much of the character and the scenic appeal of the landscape, and it also is a major contributor to its sense of naturalness. Scenes with land, scenes with trees average 6.5, and without trees 4.5. So you can see a difference of 2 units in that. And here we have a graph showing the increase in tree score, and the ratings increased by 0.29 for every unit increase in the tree score. The ratings increased also with tree height. So as the trees grew higher and also more dense, then the ratings also increased up here. Gums are what we call Australian eucalypt trees, and red gums are Eucalyptus commercialensis. As you can see here, low dense trees score fairly low, and the rating is relatively low, a bit over 5, whereas tall, dense red gums rate up to 7. Dead and drowned and dying trees rated lower than healthy trees, as you can see here on this graph. Healthy trees rated quite substantially higher than dead or drowned trees. Cliffs along much of the river is lined by cliffs, either steep, sheer cliffs or sloping. And I found that the high sheer cliffs rated much higher than the high or sloping cliffs. So you can see the difference here between 7.3 for high sheer cliffs and sloping cliffs were 6.9. Using all of this information, one can use multiple regression to assess the contribution of each of the component to the ratings. The independent variables are things such as water and river reflections, the visual diversity, the naturalness, cliffs, trees and tree health. And the dependent variable are the ratings of each scene. So the models can also be used to indicate the scenic quality of scene that has not been previously rated. So here's a model which includes all of the factors. And you can see here that the algorithm suggests that 0.469 for the cliffs and then diversity, both of those factors are quite high. The correlation coefficient 0.85 is quite high. So if you plug in all of the data for each one of these things, you'll get a fairly good estimate of its scenic quality. But you don't have to use all the factors. You can use, say, 4 of them, and this includes these ones: trees, water, naturalness, and visual diversity. And again, the diversity and the naturalness are both key factors. But you can also bring it right down to one factor, such as diversity, which is picking up that factor. And the equation, the algorithm, suggests that you could derive the scenic quality by just rating the diversity of the scene. Mapping the scenic quality involves 3 stages. Firstly, deriving generic ratings of the characteristics. So sloping and sheer cliffs, they are the examples here of what the ratings would be, and also generic ratings for different aspects of the landscape. So here we have the river at 6.7. And then looking at a cross section of the river, there's the river section there, 6.7, and different components there from the information that's derived, saying what the rating would be. And then using GIS can then map this. And so the green areas are those which are higher ratings, and the red areas are very low ratings. There's been much research carried out on the scenic value of water and rivers in particular, and I'll summarise this information. Further information involved my book, which is called The Scenic Science of Scenery: How We View Scenic Quality or Scenic Beauty, What It Is, Why We Love It, and How to Measure and Map It. It's available through Amazon, and it's nearly 500 pages and includes a great deal of information on this subject. It's also, much of that is available on my website, scenicsolutions.world. In 1972, researchers found that rapids and waterfalls were the highest rating of water scenes, and streams also fairly highly rated, as this graph shows. A further research in Kentucky found moving water was very significant in terms of scenic preferences. In the 1970s, the late Irvin Zubin carried out a fairly major study on the Connecticut River, and he found that scenic value increased with the waterland edges and open water landscapes. The scenic value increased with the waterland edge and decreased as the proportion of water surface increased. The scenic attractiveness of moving water was found to relate to how much water was coming down the river. So preferences tended to peak at a certain figure, about 1,300 cubic feet per second, and then diminished as the flow increased. And that suggests that the peak viewing time corresponded with 2 short periods annually, occurring during the rising and the falling of the waters in the late spring peak runoff. And they found this finding consistent across various compositions of scenes. And later they added sound to the analysis and found that the same peaking occurred. The Blue Ridge Parkway is probably familiar to many of you, the Southern Appalachians, and it was found in 1994, highest visual preferences along that road were for the ponds, the water bodies, the lakes, the streams and rivers, as shown on this graph. In Chicago, Schroeder looked at the meaning of the Morton Arboretum had for its visitors and found that many of its water features, together with the forest and the colours, were the most frequently mentioned features. And he wrote that the ability of trees, other vegetation and bodies of water to function as natural tranquilizers may be one of the most significant human benefits of preserving nature, which I think is a very useful quote. In England, they identified 22 factors that affected the scenic quality of rivers, and they increased with the number of trees, the number of tree trunks, depth of water, but it also decreased with the water colour, channelization of bank, percentage riverbank, and so forth. Amount of litter affected the quality of the scene. In the White River National Forest, researchers found that trail users they derived feeling states of beauty, satisfied, relaxed, and excited, because there are a lot of scenes with water there. And the water bodies contributed most in terms of beauty and for satisfaction and relaxation, but were low for excitement, as this graph shows. In London, cameras were given to 150 children to photograph 2 rivers. These rivers were fairly polluted and not particularly attractive, and the children actually photographed and focused more on the river environment. And they found the river environment were very good for play, were fairly attractive and good for wildlife compared with the water itself, the river itself. Now, what's the relevance of all of this to Virginia's Scenic Rivers program? Virginia's rivers are nearly 50,000 miles in length. That's nearly a mile of river per square mile of Virginia, which is a huge density compared with what we have in Australia, which rivers are very far and distant between. The Scenic Rivers program is 50 years old and covers nearly 1,000 miles, but that's only 2% of Virginia's rivers. The neighbouring states have quite a lot of rivers under the US Wild and Scenic Rivers Act, but Virginia has none. Evaluation criteria for designating rivers under the Scenic Rivers program is quite comprehensive, and this lists the evaluation criteria. Each of these items are scored up to 30 points and summed, and the total possible score is 385. 217 is the threshold for designation. The early emphasis on the program was in preventing dams or removing dams, but then there was a later emphasis on land and water conservation. And now the focus is on ecotourism and the livability of communities. So the evaluation criteria I found are quite comprehensive. Scenic quality is well covered. Evaluations are from on-river inspections, and it's the local community that does the evaluation and comes to a consensus of the total score. And if it reaches the predetermined level of 217 points, then it's up to the community to progress it through to designation. Due to the community involvement, evaluations are essentially descriptive rather than analytical, qualitative rather than quantitative. Reports are provided by departments on the river's environment, up to 1,000 feet or 300 metres on either side, and the evaluations are focused on the river itself and little on the surrounding land. And I'd ask, what are the planning and zoning provisions? Do they allow developments to encroach on the river? And are there changes that might occur along the route or upstream that could affect the river? Few of the local planning authorities have applied special designations or provisions to a designated river. I cite the World Heritage criteria as something which could be considered. The criteria state that they have to include areas that are essential for maintaining the beauty of the property. For example, a property whose scenic value depends on a waterfall would meet the conditions of integrity if it includes adjacent catchment and downstream areas that are intricately linked to the maintenance of the aesthetic qualities of the property. And a similar provision should be considered to apply to nominations under the Scenic Rivers Program. Overall, I believe the evaluations would benefit from greater quantification, analysis and synthesis. And it should be the aim to establish as comprehensive a database as possible for the future management of the river and its environs. It should detail the river and all its characteristics. And I give the example there of public recreational access and the need to look at what is happening there. The scenic qualities of Virginia's rivers should be comprehensively assessed. This could take two approaches. A landscape architect could carry out a full landscape description of the landscape and its components which contribute to its scenic quality, or you could carry out scenic quality assessments using people's ratings of photographs of the landscape, such as I've described earlier. And what I'm suggesting is that a Virginia-wide aesthetic assessment of rivers would provide a sound basis for future nominations. Such a survey could be at two levels. Firstly, a statewide reconnaissance of the river characteristics in all their dimensions. And secondly, a scenic quality survey based on photographs of the river types and an internet-based survey compiled. Then using this survey to sample the Virginian population to rate the scenic quality of the rivers, and the results would provide relative rating of the various rivers, features and characteristics. Provide a basis for identifying sections of the river or whole rivers that would be suitable for nomination under the Scenic Rivers Program. So in conclusion, water plays a vital role in enhancing scenic quality, as we've seen, and much research has been undertaken to describe this role. Virginia's Scenic Rivers Program is a nationally significant initiative and a real credit to those involved in it. And further understanding of the scenic quality of all of Virginia's rivers is suggested to strengthen the program. Thank you very much. That's my contact details should you wish to contact me.